They have this example on page 140. Now, on 141, I want you to highlight, oh no, this is still on your 140, still on your page 140. I want you to highlight this sentence. We are going to start solving radical equations. And a radical equation is an equation, but your variable is inside of a square root or a cube root or some sort of radical. And we have to be able to solve it. So now I'm going to go back to this example that they've given you to start with. They start off with root 5x equals 10. This is a radical equation because we have our variable inside of a radical, inside of a square root. Mathematically, if you wanted to get x by itself, it couldn't be inside a square root anymore. We have to get rid of the square root. Mathematically, what gets rid of square roots? Squaring. So that's going to be our main strategy. If you understand that mathematically getting rid of square roots is squaring, you've already figured out the strategy. We need to square both sides. So one of the things we're going to have to do, though, is in squaring both sides, we want to make sure that our square root is all by itself. So now if I square this side, in this step right here, and I square this side, well, squaring gets rid of the square roots, that becomes 5x. And squaring gets rid of the square root, that becomes 100. And then we get x equals 20. And something that's going to come up that hasn't come up in ever before in solving is you are always going to have to verify. Because this technique of squaring both sides sometimes leads to an answer that doesn't work. I'll show you why. Okay? Would you agree that, wow, we'll get rid of the yellow block. Would you agree that 9 is equal to 9? Okay? I'm going to start with something that's not true. Put a line through it. I'm going to start with something that's not true. I'm going to square both sides, and I'm going to get something that is true. Everybody agreed that 9 was equal to 9. Nobody here was like, 9 is not 9. No, everybody agreed that 9 is equal to 9. But I can start with something that's not true, square both sides, and make 9 equal to 9. What would I start with? What would be on this side that's different than this side? And then I square both sides. I get 9 equal to 9. Can you see that if I started with minus 3 and plus 3, and I squared my minus 3, and I squared my plus 3, I would get 9 equals 9. But I started with something that's not true. So we're going to find out in this unit, sometimes when you square both sides, you get something that's not true, so we always have to check. Okay, we're ready for example number 1. A 3 equals 4 root x. Do we have our term with the square root by itself? Right? We're going to isolate. Is our term with the square root by itself? Yes. Can we square both sides? Squaring 3 gives me 9. Squaring this will give me 16 times x. Because the square root of x times the square root of x will be just x. We don't need the absolute values because this is defined only when x is positive to begin with. So it's going to be confusing because we had that absolute value stuff. And then if I wanted to get x by itself, oops, that's wrong. We have to divide both sides by 16. We get 9 over 16. We have to do a check. Our check always looks like this, left side and right side. The bell goes will finish up A for sure. Okay? Left side was, in my initial question, a 3. The right side had a 4 and then a square root, and I plug in x, which is 9 over 16. Can I square root 9 over 16? Yes, it is 3 over 4. And then fractions cancel. This is 3. It verifies to exact same thing on both sides. Therefore, we know that our answer is correct.